Quiz question. What is a var expression for? Well, it represents a variable that needs to be resolved, right? Okay, a variable that needs to be applied in an environment. What's a lit expression for?
Lit expression.
Nope. Lit expressions represent literal values like 5 or 1 or 3. Values, but non-variable based values, right? We don't resolve them in an environment because they're just a value. What is a lambda expression? Okay, and what do they represent? What do we use them for?
Assigning shit to other shit.
Aren't they kind of like methods? We apply the body to the parameters that were passed in. So lambda expressions are our representation of functions, methods, however you want to say it. What are app expressions? An example of us. What are app expressions an example of? Typically, when we call an app expression, what's the first parameter? Okay, and what kind of animal are these operators typically, based on our current language? A lambda. Okay, so the first parameter would be a function. Second parameter would be a...
What we apply the function to?
Yeah, what we're applying the function to. So an app expression would be a function call, applying the function to inputs and actually resulting in a value, which is what we've been writing for 2 days. Make sense? All right. So, also, even if you sucked at it, you did better than the people who aren't here. Who knows? All right. So.
I purposely said it kind of under the costume.
I have a bidirectional microphone in there. All right. So, you had a homework assignment, right?
Yes. Extend.
This guy?
Yeah.
Extend env for lambda. All right. So, this guy was supposed to take in a current environment, a list of variables, and a list of values. Now, why are we writing this in the first place? Give me some context. What, a mean instructor?
You all want to crucify Amish now for the scope thing? Yes, please.
Oh, the scope thing's not that bad.
It's pretty bad.
Oh, I guess we'll find out in a second. I haven't really thought about the problem. So, that's why I give it to you first. So hopefully you can solve it.
There's a certain amount of hostility in the room.
Well, it's not that bad, is it?
Just
All right, well, just fine, whatever. First, answer my question, and then we'll talk about how bad it was. What is the purpose of this guy? Why do we need to extend an environment specifically for a lambda? This is what we were talking about at the end of class last time, related to an app expression. We just said a second ago, an app expression is when we have a lambda, a function, and we have values being passed into that function. So now we have the variables that the function expects. We have the values that are going to be associated with those variables. Why do we need this function? For?
so those var val can be used in that environment.
Okay, because we're ultimately going to execute the body of that lambda in the variable environment that has been extended with those var value pairs. That is, the variable names that the lambda is expecting and the variable values that our app expression has provided. So we have those two lists. We're now going to extend our environment with those, and then we're going to execute the body of that lambda with that now extended environment. Make sense? All right. So what this guy's supposed to do is he takes in that list of variables. And where does this guy come from? Who provides the list of vars? Give me some specifics, as opposed to the list of vals. Yeah, the list of vars parameter list is our list of vars, right? The list of vals is the Where do they come from? Assuming we're calling it correctly. Yeah, the operands of our app expression, right? So that's where we're marrying those two things together. The car of our app expression is going to be a lambda, which will produce for us the variables it expects. That's our list of vars. And then the cdr of our app expression is going to be, well, the car of the cdr, right? Depending on how we represent it, doesn't matter. The rest of the operands part of our app expression is going to provide the values for those variables. So now we're passing those two pieces of information in along with the current environment that we're operating in, and we're going to extend that environment with a new scope, that is the scope associated with this lambda, the local scope that's being born for this lambda. Okay, so we know we're going to need a scope, right? And we already have an empty scope guy here. And then we have the ability to extend a scope with a var-val and a scope. Okay? So I need to take every one of these list of vars and every one of these list of vals, and these guys should be equivalent length, right? Unless, if they're not equivalent length, what does that mean? If we call this function and list of vars and list of vals are not the same length, what happened? What does that imply? Tell me specifically how they screwed up. They input the wrong number of parameters, right? So they either gave too many inputs for what the lambda expression was expecting, or they didn't give enough inputs for what the lambda expression was expecting. One of the two. The lambda expression is going to say, I need A and B. Therefore, we should give them 2 and 5. Same number of values for the number of variables it's expecting. All right? So we can assume that if we're calling this correctly, that this list and this list are identical length. All right, now we need to turn these guys into a whole bunch of var value pairs, because that's how our, whatchamacallit, dealy-ma-flippy thing works, isn't it? That's how we extend. So we create an empty scope, then we extend that scope with individual var value pairs and scopes. Right? Okay. So this guy right here, probably going to need a helper function for this guy that maybe takes in a, so let's call this define extend env for lambda helper. Oh, that's an awesome name. This is going to be a lambda var val scope, right? Go with this for right now. And what's this guy going to do? He's going to extend, what I called extend scope. There we go. Extend scope, passing it the var, the val, and the scope. So this guy will ultimately it'll boil down to an extended scope. We leave it just like that. And we want to call this guy how many times? We're going to call him every single time we have another var val. Okay, so as it's written right now, we could just keep calling extend scope, but we're going to need a function that's going to ultimately give us an extended scope. Okay, so we need something to pass it to that actually constructs it for us and spits back a scope that we can then use. All right, so let's go back to our pattern here. So we need our structure that's going to go through every element of a list. All right, so as long as there's still something in low vars, so let's do this. Let's do a cond. Actually, let's just do an if. No, let's do a cond. Null low vars. And let's do this not null low vars. So as long as there's something in that list of vars, what are we going to do? We're going to call extend env for a lambda helper, passing it the car of list of vars, the car of list of vals, that scope. Okay, so probably initially the empty scope. That's going to be what we need to build upon, right? All right, so we're going to be going down some weird paths here. So we're going to say extend env for lambda helper. And we're going to pass this guy the car, let me kick it down a line, the car of LO vars, the car of LO vals. Then the first time through, we're going to have to give him the empty scope. So we need to figure out how do we get the empty scope in there. So we'll go ahead and pass him the empty scope right now. We're going to have to figure out where that came from. All right? Oh, thank you. All right, so right here, this is going to give us a single scope. Correct? This gets us a single scope, and we're going to continue to pass this scope into what? Into extend env. Now, right now, extend env takes in an environment, not a scope. That make sense? Takes in an environment, not a scope. Well, really what we need is we need to build up a scope, then extend the environment with that scope. Does that make sense? So really what we need is we need this guy, extend lambda helper, to take in our list of vars, our list of vals, and our initial scope, and continue to build it up in here. So that in the end, all we're doing inside of our extend env for vals, I'm going to steal this stuff here. All we're doing here is we're calling extend env for lambda, passing it, extend env for lambda helper, passing it low vars, low vals, and the empty env, or empty scope. And what are we doing with that value? We are extending env with that scope and the current env. All right, so extend env for lambda is going to take in our list of vars, list of vals, and an environment, and we're going to extend that environment with whatever extend env for lambda helper returns, passing it our list of vars, our list of vals, and a brand new scope that we are building for this lambda.
If you're only ever passing an empty scope, couldn't you just put that in the helper function instead?
You could, it will depend where you call this from. Because we're going to ultimately be calling this guy from our eval expression whenever we run into a lambda. So we either have to rely on our eval expression to say, I'm going to extend the environment, or because then he'll have to remember to take that new scope and extend the environment with it. Or we make it self-contained here where we're saying, okay, magic, I need a extended environment for this lambda that we're dealing with right now. So this guy's going to say, no problem, environments are done in terms of scopes. Okay, your fault. Yeah, I still like this implementation. So environments are done in terms of scopes, so that what we'll go ahead and do is we'll extend the environment you gave us with whatever scope you build up using extend env for lambda helper. Passing it the empty scope is our base. So what I have highlighted there ultimately builds up to be a new scope. And then I'll extend our environment with that scope. Does that make sense? We certainly could extend the env someplace else. But then we have to...
I wasn't talking about extending the env somewhere else. I'm talking about your helper function is one of the parameters that you're passing it is a scope. But you're always passing it the empty scope.
I'm only calling this once. Ever.
Yeah.
I'm always passing that guy the empty scope. This guy in here is going to get called recursively, passing a building up scope. The first time through it'll be the empty scope, and it'll be a scope with one variable value pair on it, then it'll be a scope with two variable value pairs on it, so on and so forth.
I hope you're happy.
Oh, this isn't.
No, I'm Amish. She's like.
Yeah, I know. I like.
About his own stuff now.
Yeah.
I still like the scopes. It's good. All right, so all we're expecting out of this guy is the expanded scope. All right, so now we can throw our cond in here. So cond null. So let's say not null low-vars. If that's a true statement, if low-vars has stuff in it, i.e. it has a car, then what are we going to do? We're going to call, well, let's extend the environment first. So we're going to say, or extend the scope. Extend scope, passing it the car of low-vars, passing it the car of low-vals, passing it our current scope. So that will extend a scope, correct? And what do we want to do with that guy? We want to call, here, I'm going to actually let me just steal this real quick. That way I can repaste it in a second. So that's going to be my new scope that I'm building. So I want to call extend env for lambda helper, passing it the cdr of low-vars, the cdr of low-vals, and our extended scope with the car of both of those guys. Like that. So this will recursively build up a scope, right, with a whole bunch of var value pairs, ultimately boiling down to that scope. So right now, this guy only does something in the event that we're not equal to, that we have a car. What happens when we don't have a car? Well, I'm not deconsing anything. So what do we do in the event that we actually are out of stuff? Return the scope. Else scope. So build up the scope, build up the scope, build up the scope until we run out of variable value pairs. Finally, in the end, just spit out the scope that we've built up. That scope will boil down right here, and it will be the result of that function call, our expanded scope. And we're going to use that scope to extend our environment. That make sense? All right, not so bad?
We have cheated and just kind of done it at the low level.
Done it who?
Done it at the lower level with cons and listing. Kind of just avoiding.
Well, I mean, you should use the constructors we built. Why build constructors if we're not going to use them?
Well, you,
I think we're all.
yeah, the scope thing was just not that thing.
Yeah, in my head it was just using the extend scope is like going around my elbow to get to my nose, whereas like my function was just building the var val pairs and then putting that inside the list, which accomplishes the same thing.
Oh, so you didn't even use the empty scope and extend scope.
No, we just kind of.
But doesn't this guy build a var val pair?
Yeah,
When you pass it the var and the val,
and
so
scope.
He passes the var and the val in the scope.
so if you have your function already grabbing the car of the var and the car of the val, you can just be consing that pair onto the cdr of the var and the cdr of the val, pass through the function again.
But isn't that less expressive than calling extend scope?
Expressive?
Well, yeah, I mean, when you're extending scope, we know we're building an extended scope. If we look at your code, we just see a bunch of cons and
Yep.
cars and stuff like that
But-
floating all over the place.
but-
We don't know what the heck they're for.
But
you don't know
it boils down to the same thing, right?
Sure.
So when I see the end, I have no idea that that's a scope unless I can actually look at it and go, oh, that is a scope because it has.
Right, when you see the end result. But when you're building it, knowing that we're building an extended scope has a visual benefit, doesn't it? If you go back and you look at the,
Understand what scope
if you go, well, you should, at this point you should know what a scope is.
Well, okay. In the
Just the
context of-
generic term, what a scope is. And actually, what a scope is doesn't even, in terms of how, are you saying if you know how
No,
our version of a scope is here?
Just in the context of using it within the environment, it seemed rather backwards.
Why?
I didn't think backwards. I just thought redundant. But
Yeah, it just
it makes sense when you're doing it here, and it does. You do. I think you do
When
see
you-
it better.
Right. So your guys' point is this. So, I mean, this is important because this is an important learning opportunity. So your point is, well, it ultimately boiled down to the same thing, right? So my question would be for you: why did we bother making constructors? What value do these constructors give us?
oh, there's significant benefit when you're not dealing with.
Because we're abstracting like this, we make changes to extend scope or it's just somewhere else. Then those changes are just automatically
They fall through,
yes,
right?
They fall through.
For everything else. Also, when we're reading it, if we take where's this function? This guy down here. Just at a glance, you could try to follow the logic, but just at a glance, we know we're doing environment stuff here, right? We see extend scope, we're using that constructor. We see extend env, we're using that constructor. We see scopes, we see envs. We know we're working with an environment in this part of the code. Where if you take your code, which ultimately is going to produce the same thing as what you're saying, right? Fine. Okay, when you take your code, if we look at that in 2 months, it's just going to be a random selection of conses and cars and coulders, and we really have no idea where in the world it lives.
Legacy code.
Okay, well, no, I get it. So, and the punchline is for this individual assignment, it doesn't really matter. But understand that we wrote these constructors for a reason, because they do make our lives easier. Right? If we can do things in terms of these constructors, wouldn't you agree that what we're writing here is starting to get pretty complex? I mean, there's a lot going on here, right? Okay. And this language doesn't even do math yet. Right? We can't add stuff. That's coming next. Okay? So imagine how much bigger a general purpose programming language gets. That does all sorts of stuff. We're going to be doing that. We're going to be implementing recursion. We're going to be writing loops. We're going to be doing conditionals. We're going to be writing all that stuff, building those things into our language. We need to give ourselves as much benefit as we possibly can to minimize our number of mistakes. Okay, because our head already hurts when we leave class, right? Right, Joel?
Man, it's like
I spent 4 hours crying after every class. 4 hours!
You drilled lists into us so much, we just want to keep going back to them.
All right.
It's your fault.
So I assume we don't have to test this code, it just works? All right, so let's see where we left off here so we can make sure that actually gives us an environment. All right, here's an exp. So we have a lambda that's taking in a single a as a parameter, and it just boils down to that a. And this is our app expression, right? So this is an example of our app expression that we're storing inside of an expression. So its second parameter is our single input. Right now we only support one input, right? So when we call run program on the parsed version of an expression, and let me just go ahead, I'm going to call parse exp on an exp, just so we see that. Run this real quick. We didn't get that far? Okay. It's because of our lit expression. Not a big deal. Okay. Do we at least... Here, I'm going to dump the run program real quick. Except that's not how you do it in this. Semicolon? There we go. All right. So that's an eval expression. Oh, that's this guy up here. Well, no, define run program, eval expression, LCE. Am I calling something like that up there?
go up to the con.
Or was evaluating it?
Eval Expression.
It was evaluating it. It gave that was a 5.
Right, but I'm not calling eval anymore. I'm just defining it and parsing it.
It still has to.
Yeah, he still has to build it.
Yeah.
Still has to-
Oh, I know what you did. You go back to it.
The error's down.
No. Yeah, the
Right
red.
Yeah, but I'm never calling that guy.
What was
Doesn't
it?
matter.
Oh yeah, because
Oh, you have one extra
there was some.
parenthesis.
I had
You
this.
have one extra parenthesis.
Oh no.
Oh no. Oh yeah. Your parentheses in the wrong place. You have to make it have a parenthesis after the lit expression.
Take it off the end and then add it after that.
Yeah, you gotta have one after lit.
Oh, for this.
Yeah.
I gotcha. Oh,
Yeah.
so it wasn't even running it. This was the syntax error.
Yeah.
Yeah.
All right. So now we were saying if it's equal to a lit expression, boil down to just that literal value. All right.
Now you can test it.
All right. So this gives us our parsed version of our guy, right? So we have an app expression whose first element is a lambda expression and whose second element is a lit expression. All right. And ultimately, we want to call our when we get to the lambda expression part of it and we call extend env for lambda, we're going to pass it this list along with this list. So the list containing the 5. So that would be the cooter of this guy. Extend the environment and then call eval expression on the body, this guy, which is a var expression, on the environment that we extended with this. Okay? So let's see if we get that far. So when we call run program, let's just trace and see what it's supposed to do right now before we run it. Run program calls eval expression on that entire app expression, passing it the empty environment as a starting point. Okay? So this is our expression. The very first thing that's going to happen is we're going to figure out that it's an app expression. So we come in here to eval expression. It's not a lit, it's not a var, it's not a lambda, so it must be an app expression. All right? So that's what this guy says. So else, if we are dealing with the lambda expression as the car, right? Okay, if the car of the car is a lambda expression, this guy right here, then what are we going to do? We're going to evaluate the expression. What expression? This guy right here, the body of that guy. In what? In the environment extended, so extend env for lambda, passing it this guy, that's the parameter list, and passing it, let's see, this guy right here, these guys are potentially lambda calculus, they are lambda calculus expressions, so we're going to call map lambda x, passing it eval-expx on the environment, which is going to be a waste of time in this case since it's just a 5. So we're passing this guy in to eval expression. Ultimately, we should get just a 5 out of this. All right, but that's what we're doing here. So we're mapping across this list, this function, which takes in each element of that list along with the current environment that we would be evaluating it within. Ultimately producing, what does map always produce for us? The output of map is always a list. Okay, so if we map a lambda that just squares a number across the number the list 1, 2, 3, we'd get a new list with all the elements squared. All right, so map always produces a list. So this is going to be our list of vals. Right there. So we're calling extend env for lambda with the list of variables, a list of vals, and the environment that we're extending. So this guy right here is going to give us a brand new environment with that new scope added to it. And what are we doing with that? We're calling eval expression on the body, this guy right here, passing it this new environment. Okay, the environment that's been extended with our variable value list. So Here's eval expression. Here's our new awesome environment. Here's the lambda calculus expression, which is just going to be this guy, the body. That guy's a var expression, so we ask, is it a lit expression? No. Is it a var expression? Yes. So let's apply the NV, passing it the A, carve the cooter, in our extended environment, which should give us a 5 in this case. There's our 5. That make sense? So we have a running program in our language. We are applying the input of 5 to the function that takes a single input and outputs the variable after being resolved, which in this case would be 5. Now I think this should work in our current environment. If I say AB and I say 5, 6, whoa, hello. I think this should give us the 6.
Doesn't that need to be a list?
Yeah, that's. I was wondering if we had written it to support it as more than one. I said earlier I didn't think we did, but I thought that map should actually work. But what's breaking is actually our eval expression. Oh, it's so this guy's coming in as not a list. So right now, this guy only works on this, but if we change this to that, which I don't think is what we ultimately want, no, that breaks it the other way. Yeah, so right now we can only work on simple lambda expressions. We'll fix it for the bigger ones here in a second. All right, so this will work for multiple. So if I say B, and then I say 7, like this, the output of my program should just be 7. So even though I'm passing in 5 for B and extending my environment with that, my body is just a lit expression, which boils down to 7. Make sense? Similarly, though, let's see, how would that work? No, we can't do a lambda in our current language. That's not going to be good enough. Okay, so now let's make this work for our more complex. So now we might have a lambda that takes in a list of parameters, and we support this already, right? A list of variables. We can't do a whole lot with them yet, so we still have to choose between A and B as to what we're going to do here in the body, since we don't have built-in like math functions and stuff like that. But let's get it working so that we can pass more than one value in.
Couldn't you just put a list of lists showing A and B in it?
You mean right here? Well, except our, I suppose you could do an app expression that has A and B in it. Yeah, you could, but it doesn't do anything still, right? Just boils down to those values. So it's not productive at this point. All right, so now we're going to try to take in 2 parameters. We're going to pass at those 2 parameters. So what we need to do is we need to look at this code right here, because this is where the magic is happening. And here, let's turn this into B. So we're hoping to get a 6 out of this, and right now I think it still crashes, right? So what I'm going to do here is we're going to take, we know we're looking at a lambda, so we're going to take this guy right here, and we're going to piece it apart inside of our, oh, wrong, I guess Apple just abandoned the recent menu, no longer necessary. Oh, that's not really what I want. I want this, then this, then this, then this, then this. Okay, this is the expression we are trying to evaluate. All right, now let me go back in here and let's not run the program, but we still want to get our parsed expression. So this is our parsed expression that we're currently operating with, so we know what it looks like. Okay. Now, ultimately, we know we're dealing with an app expression. We know that we're dealing with a lambda expression. So now we're right here. This is that if we're dealing with a lambda expression whose car, if we're dealing with an app expression whose car is a lambda expression. That's what this code is right here. Okay. So we're going to eval our expression, giving us, what's this guy? This is the body. So that's going to give us this piece right here. That's the expression we're evaluating. Okay? So what we're going to do is we're going to go ahead and, well, we can inline it with this. So we're going to go ahead and we're going to copy this. And I'm going to replace that here with that. We're going to say we're good there. That is the body of our lambda. Okay? That's the expression that we are going to try to evaluate. We all agree on that? Worked before, nothing we've done has broken that. What's broken is this last piece. Okay? Now, we're extending our environment for lambda. This guy expects us to pass it 2 lists and an existing env. Existing env we're good with. I think the first list we're also going to be good with. So let's look at that. So this first list is going to be this list right here. The list AB. So we can go ahead and, so this says give me the, this guy right here says give me the lambda expression. And then this outer guy says give me bucket 1, the second element of that lambda expression, which is the list of variable names. Right, Abe?
Yep.
So what's on the screen? I don't want to say. I don't know about you guys. This isn't easy, right? One would think paying attention might. Maybe it doesn't. Maybe we're just so out there in here that maybe paying attention doesn't really help. I go home and I watch the video backwards, and it just makes more sense. All right, so we're going to do it anyways. All right, so this guy will boil down to that list of parameters. Bucket 1 of our app expression. All right, so here's our app expression. This is bucket 1. This is lambda here, right here. And bucket 1 of that guy is this guy right here. Make sense? So what are we passing into our extend env for lambda? This guy right here is replaced with that guy. So far, so good? All right. Now, what we want to get next. Okay, what we want to get next is going to be our, should have a 5 and a 6 here. Instead, we just got a 5, which tells us that we have a problem with parse. Huh?
Doesn't that have to be in a list? Because the app expression, wouldn't it just read?
It shouldn't be. If we're trying to make it match scheme, it shouldn't be in a list. All right, but so punchline here is that currently we are not getting our parse is not doing its full job yet, right? We need to fix parse up a little bit, okay? Because we really should have a second lit expression here. So probably we want to have a list of lit expressions. So if we go to parse, here's parse expression. So if we're dealing with an app expression, we're calling it, we're going to say call parse expression on the first element. And then what are we doing is we're going to, right now we're calling parse expression on the second element. What we really want to do is we want to map parse expression onto the rest. Does that make sense? So right now we assume there's only 1 second parameter right there. Call parse expression on bucket 2, the car of the cooter. When really the cooter is going to be the list of operands. And we want to map parse expression across that list of operands. So we'll call map parse expression on the cooter.
I can give one extra.
No, I think we're good. All right, so now we have our list containing our list lit 5, lit 6. All right, now while we're in here, let's go ahead and fix unparse. So we just changed parse. And unparse is supposed to be able to unparse a parse. So what does unparse do when we see an app expression? We call unparse on the car of the cooter of that LC struct, when really we need to map unparse across the... Let's look at what this guy looks like. Okay, so this guy says if we're looking at an app expression, we're going to call unparse on the catter. That's this guy. And then we want to map unparse across the car of the cooter. Because the cooter is going to be the list containing this list. Yeah. The cooter of this guy. Oh, no, it's the cooter. Because it looks like this. The cooter will be the list containing this. The cooter of that will be the list containing this list. Then we want the car of that, which will be just this list. Just that list right there is the car of the cooter. And we want to map unparse across that. Okay, because now we're not just assuming it's one thing. Right now we're just calling unparse in that one element, where really we have a list of unparsable things. So we're going to call map unparse across the car of the cooter. All right, so let's make sure it gives us our function back. So let's just call unparse on this. Make sure it brings us back. Unparse the parse. Oop. Okay, thanks. All right, so that still gives us the list 5, 6. When really we want it back to just a flat 5, 6. So it's doing everything but getting rid of this list, which means that we need to append, right? So in unparse, oh, we're using our constructor for app expression. So we need to go up to our constructor for app expression. And this guy's creating a list of the raters and the rands, where really we want to append rater and rands, right? I think we want to append the list out of rater onto the list out of rands. No, the list out of rater onto rands.
Wouldn't that still create a list?
I think we want this. Yeah. Okay, so that's our list of things. So this is our lambda, and this is the parameters. So we had to use append up here in our constructor. So point what you said, since we only made the change to our constructor. So now since we made the change to our constructor, even though we're calling the constructor later on, we just had to fix the constructor here and everything else worked. Okay, reason to use constructors. All right, so I think parse and unparse work now, which means that, let's just go in here real quick. That are let's just get our new version of our parsed output. So now a guy looks like this. Okay, so let's just replace this in here with that. Okay, so now we have our body. We have the list of vars. Now we need to get the list of vals. So we want to map this function, the function that takes in a single parameter and calls eval expression on that single parameter, giving it the current environment. Okay, and we're going to map that function across the CDDR of LCE right now. This is LCE, our parsed lambda calculus expression. So the cdr is going to be the list containing these two things. The cdr of that is going to be the list containing these things. We want to map this function across that list, which is going to produce a list of flat things. So now I'm mapping eval expression across this list right here. That's this guy right here. So the CDDR, actually let me think about that for a second. The cdr is this list. The cdr of that is the list containing this list. So I need the car of that to give me just this list. Correct? Yeah. Cdr of this list gives me the list containing a list and another list. The cdr of that gives me the list containing this list. I want just that list, so I need the car of this guy. So I'll map this function across the car, and now we actually have a list there because we have our, that's what changed when we did our append. So now we do CADDR of LCE, which should, in this case, boil down to the list 5, 6. That's what we're hoping here. Let's kind of test this. So if I take this here, I paste that there, and then we take that function, come in here, let's paste that. So we're going to map this function onto this list.
You gotta hit enter.
Oh. Oh, I didn't have an env on. Empty env for right now. We get the list 5, 6. Okay, so that means all we should have to change up here now is, where's my map? Eval expression, this guy right here, it's the CADDR of that guy. So now I should be able to run this program, and it's going to pass in 5 and 6 for A and B, and then boil down to the value of B, which should be a 6. And there's our 6. Make sense? All right, so hopefully we're already at the point now where we need to take pieces of our interpreter off to the side and explore only those pieces. Because if we try to operate inside of this wall of scheme, parts of our brain will fail. Okay, I mean, we can't. I can't look at this as a whole and be able to piece things out. We have to compartmentalize and look at individual little pieces. Right? And then we have to just know what works and what doesn't work. Okay, so now, let's see. You wanted to create a body AB like that, Curcio? Yeah, see, I don't think we can't evaluate that because that's in our eval-exp. That's if we're looking at a car who's not a lambda. So right now, inside of eval-exp, I'm trying to pass the body is actually an app expression, right? That's what that guy is. Body of that guy is a app expression. List. Oh, he doesn't even get parsed as an app expression, actually.
Because it's just putting it.
The app expression. Oh yeah, here's the list A and the list of the list. Oh, it's because that second guy is a list of a list. So it's trying to, which is correct. It's trying to apply this function to these parameters. That's what an app expression is supposed to do. So really what we should say is this doesn't make sense. A is a var expression. That's what this guy is right there. He's a var expression. And we're going to try to apply to that var expression this list of var expressions. So right in here, what do we say? Well, if the car of it is a lambda expression, which in this case it's not, we call eval expression. Otherwise, what do? Well, we just create a list calling eval expression on the car of it and eval expression on the catter of it. Okay, well, really what we probably want to do is we probably want to just map for our catch-all right now. We probably just want to map eval expression across that guy. This guy right here doesn't necessarily make any sense. This is what do we do with an app expression in the event where the first element is not a lambda. That's what that code is for. Okay? If I'm looking at an app expression, something that is technically an app expression, but the first element of it is not a lambda, i.e. this guy right here. Okay? The question is, what do I do? What do I do with that guy? Okay? What do we want to do with this guy? If we're looking at this, well, I can go ahead and I can eval expression on that guy, and then I can map the eval expression across that guy, and then what, just boil down to the list? What I'm asking you is from a language perspective, what do you expect to get as a result? Does an app expression make sense in any scenario other than, think about from all the programming languages you've worked with, does an app expression make sense in any scenario where the first element is not a function? Aren't we always applying parameters to a function? Give me an example if something else exists. Well, ours will work for that. When we could say we want nothing. Actually, that's a good question. Actually, will it work for no inputs? So this takes no parameters. We give it no parameters. It boils down to just the lit expression that we had there. So that's legit enough. So we support no argument functions. But what is there a construct that we're missing? Can you come up with an example in Java when we have what is our equivalent of an app expression, that is applying some inputs to a function where a function does not need to be there? doesn't exist, right? I mean, the purpose of an app expression is that's our mechanism for shipping parameters into functions. That's what it's there for.
I mean, if you want to get technical, I think you could. Generics might be that kind of in the box, kind of sliding it along.
Not inside of eval expression.
No.
Yeah, I mean, we have to look at this in context and say, okay, well, we're currently trying to evaluate an expression. If we're evaluating, I mean, you're talking about language representation. Yeah, so fine. I mean, that's fair enough. But if we're inside of eval expression and you've given me something that's an app expression, you're telling me you want me to take this crap, the right-hand side, and send it into the left-hand side. Therefore, this guy... Oh, I got to go back to where I was here. So this was AB, then AB, something like that. When would this make sense? Our language doesn't currently support it, but when would this make sense? Our language will support it soon. Well, it certainly would make sense if it was math, but then we would have to have passed it in the... Oh, I'm sorry, actually. Let me finish writing this, shall I? There's the lambda, so let's just say 1, 2, something like that. So that doesn't make any sense. What would I have to change here in order for this to make sense in our world? This guy needs to be a function, right? But if I make that guy a function, what are we doing with that function in this app expression? So let's just say we have a function that exists called plus, the plus function that does math, adds stuff. When would this make sense? Plus is coming in for, variable A. And now we're applying A to the rest of the parameters. So maybe we take in B8, something like that. So we're taking in 2 inputs. The first input is actually a function. So we're extending our environment not with a value, but with a function. Then we're taking in a second parameter, which is a 2. Then our body is an app expression, whose first element is a variable A, which resolves to a function. And then we're applying that function to these inputs. B resolves to 2. 8 is a literal expression where it resolves to 8. So assuming that this guy was actually written, this guy would boil down to 10. That make sense?
That can be your homework.
Not that deep.
No, that should be fun.
Yeah. Okay. So keep in mind, there's 2 pieces to that. One piece is we need to be able to pass in. Well, there's 2 pieces to what I just talked about. One is our environments need to be able to be expanded to hold functions. That is, right now we have variable value pairs, where the only kinds of values we hold right now are integers, right? We have a language of numbers right now. We can hold integers. That's not a big deal. We're fine with that. Okay. So now we need to make this work. We would need to expand our environment to no longer only be able to hold integers. Now we can hold values of type function, lambda expression, however you want to think about it. Okay. Things that we can then apply to other things. Things that are legal operator parameters to an app expression. What would it take to expand our environment to support lambdas? Think about our extend env for a lambda function. That takes in a list of variable names. That wouldn't change, right? A, B, C, same thing. But then we take in a list of values. Right now our values are what? Lit expressions or the evaluated. When we could throw a var expression in there, couldn't we? Yeah, we're mapping eval expression across it, so we'll be okay with that. Okay, so right now we'll say lit or var expressions are legitimate inputs for us. Okay. How would we pass in a function? How do we represent functions in our language? Lambda expressions. So our language supports the representation of functions. It also supports applying those functions. Because those functions are extremely simple, correct? So right now, our functions can take in 0 or more parameters and really only spit out one parameter. So what would happen if we had a lambda that looked like this? Let's see. Let's have an expression that took in an A and a B, and we applied A to B, and the parameters were lambda x, x, good enough. Okay, yep, something like this. So now I have an app expression whose operator is that guy. This is a guy that takes in two parameters, A and B, whose body is the guy that is an app expression where we take the operator A, and actually I need to flip these two things around real quick. I don't remember what I had. Let's just say it was a 5. So, say this again?
You're only passing one parameter in there. Okay.
Yeah, no, I'm fine. All right, so we have the operator, this guy, is a lambda that takes two parameters and applies the first parameter to the second one as an app expression. The parameters we're passing in for A is a lambda. For B is a 5. Now we're applying A to B, where A is this lambda expression, where we would call eval expression on this guy, passing in 5 for x, and it should boil down to the value of x. How many scopes get created here? Well, we get the first extended scope is the scope where we extend the empty environment with an environment now that has a single scope with two variables in it, A and B. A's value is lambda. B's value is what? Is 5. So this is A. This is B. This is an app expression, correct? The car of that guy is the operator. Everything else is the list of operands. First operand is a function. Second operand is a lit. So we'll extend our E and V with A and B. A being our function, B being our lit. Then the body, we evaluate the body in that extended E and V, correct? So now when we call eval expression on A and B, passing it our newly extended environment, we're going to notice that this guy is an app expression. And what are we going to do with that app expression? Well, we're going to take in A. We're expecting that guy to be a lambda, right? But actually he resolves to a lambda. Does that make sense? Right now, it only supports, I guess for lack of a better phrase, lambda literals. Things whose cars are lambda, lambda exp. That makes sense? But now I have a variable. So right off the bat, we might say, well, in our current implementation, this doesn't make sense. I need to apply this dude to this dude. Okay? But before I can apply this dude to this dude, I have to resolve that guy. I need to be able to get that lambda expression out of my environment so that I can apply it to the other guy. Does that make sense? For your homework, do one little tiny piece. One little piece. Update. Extend env for lambda to support storing an expression. So now we can store both literal numbers and we can also store expressions. That make sense? I'm going to give you a hint. You might choose to store a parsed representation of our values in there rather than pre-resolving them. Right now, when we call extend env for lambda, what are we doing? We are mapping eval-exp across our environment. If we have lit expressions, they boil down to just 5, right? Wouldn't it be easier, potentially, to actually store the unevaluated expression? So instead of boiling down to 5 and 6, we actually just store A is equal to a lit expression 5. B is equal to a lit expression 6. C is equal to a lambda expression whatever. So then when things come out, they come out as expressions and then we need to evaluate them. That make sense? Okay, so for your homework, all you're doing, and this will break the second part of the program. So if you try to run this, it will break afterwards. Okay, so just test this one piece here. Fix extend env for lambda and extend env for lambda helper so that it can take in lambda expressions as part of the list of low vals and store those. All right, so it can store associated with our variables any type of expression. Expressions then become first-class objects like lambdas are in Scheme. Okay, so I'll give you this code as a starting point. Should not take overly long. All you're doing is modifying the code we've already written here to store things that really it already knows how to store. Okay, you're just shoving it in there. Okay, we'll have to phrasing. Okay. Next time we'll take it out and figure out what to do with it. Also phrasing.
Yeah, probably.
All right. I'll see everybody on Thursday.